Well, time to take these two apart. I got them in an auction. I'll link it at the end of the video. But there's a huge difference in quality between this one here that was made in the USA back in 1961. So you can do the math. This thing's old and it still works. This one here, on the other hand, I did have to take the screws out because these were rotating, meaning the switch was rotating, and I didn't want to break any bus bars inside. So I have seen what's inside this one. Now, this one here, if you go looking for that on eBay, internet, anywhere, I could not find any reference to it at all. Some look similar, but the screw holes were all different. So this one seems to have pretty well disappeared off the face of the earth relative to the internet. This one here, you can find lots of information. Back in 1961, they were selling it for $315 US. That's a lot of money back then. Now, if you want to buy one off of eBay, it costs you about $380 US. So, not too bad. I'm going to do a quick thing on this one. Then I'll show the insides of this. Then I'll go to this one at whatever time's in the corner if you want to just look at the quality one. So, you can see this on the numbers. It's drifting around. This goes from, well, 0.1 microfarad increments. On the low end at 100 nanofarads. So, let's just see what happens. Okay, I'm already... crap. There will be a slight break as I put new batteries in my meter. So let's... Oh, I got new batteries in there. 0, roughly 0. 100 picofarads. Close. 200. 300. 400. 500. 600. 700. 800. 900. And 1,000. The issue, since I've already looked inside here, is the contacts. They're in really bad shape. So, I'll just... There's 0.001 microfarads. And I have to change the scale here. Should be roughly 2 there. 3, 4, 5, 6. This is going to get boring quickly. But let's take a look inside. So there's the setup. I'm just going to move things around for a moment and then bring the camera down. So the switches actually just simply need to be cleaned. And that was most likely the problem on most of this. Now, the capacitors on this, though, Noble, and I believe that is actually Japanese capacitors. Just 2%. They're all 2% capacitors. Quite nice looking capacitors, but they're 2%. So that kind of gives you an idea how accurate this one's going to be. Let's see. Other than that, it's not too bad. You can see why I was afraid about trying to tighten the knob without getting my hands in here. But we're going to compare this against that one. So let me just reset the camera. So on this one here, the lower scale's down here. 1 nanofarad, 2, 3, 4, oops, 5. This is supposed to have 0.0 or 0.5% accuracy. 6, 7, 8, 9, boring 10, and you're going to have to change the scale here. And this is very smooth. The other one was excessively rough. Not bad for something that's 60 years old. And oops. Six, 7, 8, 9, 10. And this one actually can go all the way around, whereas the other one you had to back it up. So let's open this one up. I took a look at the spec sheet, and apparently this has silvered mica capacitors in it, whereas these are polyestrine, maybe? I'm not sure. I couldn't find specs on this at all. So let's flip this over and take a look inside. And on this one, that's where they're hiding the attachment. Let me find a screwdriver. And this should be very quick. If I run any snags, I'll fast forward. I always like this metal finish they had on these. And the last one. There we go. No date on that. I'll just move it to the side. And oops, I'm going to have to move the camera around a bit. So there's not too many parts you're going to be able to change in this. The capacitors are actually potted in here. And as I said before, they're supposed to be good to 0.5%. So there's the banks here. Look how sparkling clean this looks. So I'm betting there's a bit of stainless steel in here because there's no signs of rust. And this thing is 65 years old. Hopefully I can find a date on something. Radio Company, Concordia, Massachusetts, USA. I'm going to have to try to get the camera set up so I can get right at the switches. So there's one of the switches. Definitely a lot beefier than, oops, there we go. Hard to get a good look down in on these, but definitely a lot beefier than that. And everything in there is nice and shiny. Doesn't look like the contacts are gold. Oops. but obviously it's done the test of time quite nicely. There we go. So there's the difference in quality. This thing weighs 11 poundish, that weighs 2 poundish, and these are silver mica capacitors, and those are poly somethings. Well, I'm not going to even try to take this apart because this thing is just so nice. This is going to be a good piece on the bench. So I hope you enjoy it. Coming up in just a second or two is outside weather, which is why I'm now making more videos. Have a good day. Bye. I changed my mind and decided to give this one a fighting chance. And I've got some contact cleaner and see if I can get this cleaned up enough that it works better. I don't have any of those fancy abrasive brushes, so I'll use a Q-tip. That was just to get the big stuff. Give them all another shot. And then do the old standard back and forth. Clean up the contacts. Oh, this one's actually loosened up again. How many times do you do that with pots? They've got a bald spot on them. Now I'll just do a bit of cleaning. Yeah, that didn't do too much. But I'm going to let it air, and then I'll stick it back in the box and see how the numbers come out. Improved it a bit. I'm going to shut up and I'll fast forward it so you can just see the numbers. So some of the numbers are still off. Probably just needs a lot more cleaning in there. I think that translates to if you're taking my picture, give me food. It's the weather has definitely changed on the west coast of Canada. We're into fall season. Oh well, at least I can spend more time doing electronics.